I hope you are all having a great day. I am Mr. H. Thank you for joining me. Let's do a video here, Circle Computations, where we're looking at two standardized test questions. We have a representation of a circle here with a triangle drawn. The long edge of the triangle represents a chord with a length c. We have to determine that length c. If the radius is 2x, we have a certain angle here, theta. You cannot assume that to be 90 degrees just because it looks like it. We know we have a radius here, we have a radius here, and this here is my center. How can we determine this? Well, it's no different than you thinking about the law of cosines. Think about c over here. You'll have c squared is equal to a squared plus b squared minus 2ab cosine c. We have a cosine angle over here opposing the side c. We're trying to find this can be a radius, this can be a radius. So it's not too hard. Radius here is 2x, and you would just plug things in. C squared is equal to a and b are representing your radii. You'll have a 2x square plus 2x square minus 2 times a and b, which is each 2x. And then cosine c is a cosine theta, the angle, as you see. Open everything up. You'll have a 4x square plus 4x square minus 8x square cosine theta. And c square is equal to, combine the terms, you have 8x square minus 8x square cosine theta. C is equal to all of that under root 8x square minus 8x square cosine theta. You can isolate from here 8x square. You'll have a 8x square being isolated, and you'll have a 1 minus cosine theta. And then of course c is, you'll simplify it, root of 8 is a 2 root 2, 2 root 2. But you can write that as 2x. And then you have a 2 and 1 minus cosine theta. Think about it. I have a 2 root 2, which is the square root of 8. The x squared came out as an x, and then everything else is good. So this right here would be the measure of your side C. And you would just need the values of x and the angle, and you'd have a numerical value here for C. But that right there is your final answer. Alright, let's look over here at this second and last question. We have a circle within which we have two small circles. Here's the center of that small circle, the center of the other circle, and the center of your large circle. Everything here is tangent to each other. These circles are tangent to the center of the large circle, and everything, as you see over here, with regards to the small circles, there's a radius x. You have to find the area of this shaded portion right over here. This little shaded portion, what's its area? That's what we have to determine. Well, how about you look at everything over here with regards to the large circle. The large circle is made up of these small circles, each having a radius x. But if you extend this here, you're looking at another x. The large circle ends up having a radius 2x. That's the radius of your large circle. If you did the large circle has a radius 2x, then the area of the large circle, LC, must be pi 2x square, which is what? 4x square pi. That's the area of your large circle. Now let's take the area of each of the small circles. Each circle over here has a radius of x, therefore the area must be for the small circles, and we can write it here. Area of the small circle must be pi x square. But since there are two of these small circles, we have 2 pi x square. If you were to take the large circle and minus from it the area of the small circles, we would have the total area, which is not included in either. And you can see that you'd have 4 pi x square minus 2 pi x square, you'd have a 2 pi x square. That right there would be the area of this part right here and this part right here. But if you were to divide it by 2, because you're only looking for one shaded region, you would have pi x square, and that right there would be your final answer. So the area of this shaded region would be pi x square. But of course the area of this unshaded region would also be pi x square. Pi x square, pi x square, and each of these individuals here having pi x squares, you'll see all of those 4 pi x squares add up to a total of 4 pi x square, which of course equals the large circle because everything is included within the large circle. Anyhow, this right here is the area of the shaded region SR, and it's pi x squared, and we're done. Thank you for watching. Have a nice day.